Hey guys, welcome to video 5-4. In this video we're going to be talking about another shortcut for triangle congruence called the side-side-side triangle congruence theorem, and it shouldn't come to you as any shock, I don't think, that you are going to be looking for three pairs of congruent corresponding sides. So this is pretty quick just to walk through here. Example 2, notice again you can classify them as small, medium, and large sides kind of pairs of congruence. So first they start with AB and DE, and they're both 1.7 in length, and so those two sides are congruent. BC is the largest side. BC corresponds to EF, and those are both 2.4, so BC and EF are congruent. And then AC, the medium length side, corresponds to DF. They're both 2.3, so AC is congruent to DF. Therefore, since three sides of the triangle ABC are congruent to three sides of triangle DEF, then that means the two triangles are congruent by side-side-side triangle congruence. In part B, as we're looking for sides there, we have DE that they're starting us off with that's equal to 20, and that's going to correspond to FG is also a length of 20, so that means side DE is congruent to side FG. DH is 12 centimeters, and the other 12 centimeter length is FH. So that means side DH is congruent to side FH. And EH's length is 24 centimeters, the longest side, and that corresponds to the other 24 centimeter side, which is GH. So I can write the third side congruence statement, which is that EH and GH are congruent. And so three sides of triangle DEH are congruent to three sides of triangle FGH. And so that means that the two triangles are congruent by the side-side-side triangle congruence theorem. See what you guys can do with here with your turn number 5 and your turn number 6. These two problems, see if you can get those pairs of sides either to be corresponding sides to be congruent or not, and that either proves that they're congruent by side-side-side or not. Take a pause on the video and do 5 and 6 before we move on. Now I'm on Explain 3, you guys, on page 260. And in this part of the lesson, we're going to be using the fact that they're congruent triangles to find missing lengths. And in example 3, we have some triangular jewelry pendants here in the shapes that are shown. And we want to know what value of x are we going to be able to use a triangle congruence theorem to show that the pendants are congruent. Okay, so which triangle congruence theorem are we going to be able to use? Well, right now we can see that we have AB and JK are both 3, and AC and JL are also both 3 because they have the same measure. So if we were to say that BC and KL were congruent, then the triangles would be congruent by side-side-side. So what we're going to do is we're going to set up an equation setting the lengths equal, and that equation would be right here. 4x minus 6 is going to equal 3x minus 4. And if we solve that, subtract 3x and add 6 to both sides, we're going to get x equals 2 for our final answer. In the same idea with part B, we have another triangular tile design here, and we want to know what value of x are we able to have these triangles be congruent by some sort of triangle congruence theorem, and what would that be? So if we fill in the blanks as we go here, it says notice that PQ is congruent to MN and also PR is congruent to MO because they have the same measure, all 4 inches in side lengths, then if we were to be able to say NO was congruent to QR, then the triangles would be congruent. Triangle MNO and PQR would be congruent by the side-side-side triangle congruence theorem. So we're going to set up an equation that makes that true, and that is that 3x minus 11, the side that you see as labeled NO, would be equal to the side that's labeled QR, which is just 4. Adding 11 to both sides gives us 3x equals 15, and of course dividing by 3 gives us x equals 5. On the your turn here, let's see what you guys can do with number 7 and see what triangle congruence theorem is going to be used, and also what value of both x and y, take them a pair at a time, okay, would be able to show that the triangles were congruent.